So what I want to talk about is function notation. But before we get there, let's think about the equation y equaling 3x plus 5. And what I want to talk about specifically when it comes to the equation y equaling 3x plus 5 is the independent variable x. So if I wanted to create a table of values, I would choose x values and I would input those x values into the equation. And then through a process of simplifying that equation, I would get out a y value. So what I want to call the x variable is the input, and then the y variable, I'm going to call my output. So let's go ahead and try this. When x is equal to 1, we input it into our equation. So I plug 1 into this, and what I get out after simplifying, well, let's simplify it together. 3 times 1 is equal 3, and 3 plus 5, that's equal 8. So my input is 1, and my output is equal 8. So let's go ahead and see how this is connected to function notation. So we can rewrite the equation y equaling 3x plus 5 as f of x is equal to 3x plus 5. And what you'll notice right away is my input has stayed the same, but my output has been rewritten. No longer am I calling it y, I'm calling my output f of x. So let's go ahead and practice this and see how it helps. Let's go ahead and evaluate f of 2. And how you might do this is to recognize what does 2 represent. The notation above tells me that the x is typically inside these parentheses. So this 2 here is actually representative of an x value, right? Here, x is equal to 2. So wherever there is an x in my equation, I'm going to plug in a value of 2 in its place. And then, of course, we can simplify this one together. 3 times 2 is equal to 6, and 6 plus 5 is equal to 11. So here, right, our input is equal to, and our output is equal to 11. So this is a nice shorthand way of telling somebody that I plugged in 2 into my function and I got out 11 out of the function. What I'd like you to do now is try the next problem on your own. So go ahead and pause this and see if you can evaluate f of 3. Okay, so hopefully you paused this and tried it out. What I didn't bring down is the function we've been working with. And if I remember correctly, that function was 3x plus 5. Let me go ahead and double check that. Okay, so what you probably had done is to recognize that the x value that we're going to be using is inside our function notation here, right? And we're going to plug that x value wherever there was an x in the original function. So I'm going to have 3 times 3, plugging in that value of 3 into the parentheses, and then add 5. So go ahead and simplify this. We would get 3 times 3, which is equal 9, plus 5, which is equal 14. So here, f of 3 is equal 14. Again, a nice concise way of telling a reader that you plugged in a value of 3 and you got out a value of 14. So let's try a different way of looking at this function notation. Why don't you go ahead and pause and try to solve f of x equaling 17. So hopefully you paused and tried this out. Well, this one looks a little different than what we've been working on, right? Where our x value is not given. We don't know what it is, but our output, right? Our output is given. And remember the output, that's just another way of saying our y value. Our y value here is 17. So what we can do is if we remember our function f of x equaling 3x plus 5, we will replace our output of f of x with 17, because that's our output. And we're going to set it equal to the function 3x, I don't know what x is, plus 5. So now this is just down to us solving for x. So if I wanted to solve for x, I would subtract 5 from both sides and get that 12 is equal 3x. And of course, this is what 3 times x is equal to. I want to know what x is equal to, so I need to undo that multiplication of 3 by dividing by 3. When I divide by 3 on both sides, on the left, I get 4. And on the right-hand side, we say that those 3's cancel, but what we actually mean is that 3 over 3, that's equal 1. And 1 times x is just equal x. So this would be me solving f of x equaling 17. I found that in order for that to be true, my x value must be equal 4. I could rewrite this answer or this solution in the form of the function notation and say that f of 4, that was the x value that I had found, is equal 17. So this is the function notation form of the answer. So one big word of caution is that when we go ahead and evaluate into our function notation, we're not multiplying, right? So it's pretty obvious if I were plugging in h into my function, I don't mean f times h, I mean plug in h wherever there is a x value on the right-hand side. It will definitely become more complicated when you start to plug in not just singular values into your function, but whole expressions like this. So you might consider this and think, I need to distribute my f into the parentheses, but that's just not the case. We're actually going to be evaluating the entire expression x plus h into the function and not multiply. So one thing you might try is to take a formal definition of function notation and reword it into your own words. This is really helpful because it helps you understand things a little bit better. So the formal definition of a function that I have is that the notation y equaling f of x defines a function named f. This is read as y is a function of x. The letter x represents the input value or independent variable, like we were saying. The letter y or f of x, right? That's something new we're learning, represents the output value or dependent variable. So y and f of x can be kind of used interchangeably. So here's my attempt at rewriting this formal definition in my own words. Let's see what I got. Function notation is a different way of writing an equation. With function notation, whatever is in the parentheses, often but not always x, that's our input. And what comes out, the f of x, that's our output. All right. Thanks for watching. I hope you have a good day.